Today I would like to talk about logarithms. Now, we've kind of already seen logarithms, but they were just written in a different form. It was written in the exponential form. Now you might ask me, well, how does that work? Well, logarithms are essentially the opposite of the exponential form. So we have kind of seen them, we just have to get used to seeing them in this new form. And we have to get used to working with this new form. So let's just go ahead and write out our basic exponential form right here. So we have our m is equal to c to the power of n. Now n is our exponent. C is our base, and m is the power. That's our answer. Whoops, I meant to write power, not answer. Now, the exponential form can be interchanged with the logarithmic form. And you'll see what I mean by just a bit. So the logarithmic form looks like this. So you notice that the exponent and the power have kind of swapped. With here, the exponent is the operation here, right? And then the power is our answer. But with this here, we can see that our exponent is now our answer. But it's not called the exponent anymore. This is called our logarithm. Our base has stayed pretty much the same. It's just now we have a log in front and the base is, written as a subscript. So our base stays the same. Now the power became part of the operation here, and we call this the argument. So you can interchange between these two forms, back and forth, back and forth. An example of this is let's say we have 8 is equal to the power of 2 to the exponent of 3. We can rewrite this as a log by saying that our logarithm 3 is equal to log of base 2 of 8. Now you might ask me, well, why does this exist? Why do we need to know this? Well, if you realized, we didn't actually look at solving for our exponent when we talked about our exponential function. We just looked at how to graph it and how to read a graph. In order to be able to solve an exponential equation, you need to know the logarithmic form as well, because you use the logarithmic form to solve for your exponential. Similarly, if you're trying to solve your logarithmic form, you need to flip to your exponential form. So this is why we need to use these interchangeably. Now, there are a couple of extremely common, the most basic logs that are out there. There's 2 of them. So the common logs, I should say, are these. The first one is log with a base of 10, which can simply be written as log. So an example would be log of base 10 of 3 is just written as log 3. Now you might find on your calculator a button that is called log. This log refers to the log with a base 10. So this is what you would use to evaluate this. The second most common log is log with a base e, which becomes ln of x, written ln. Now, an example is log base e of, let's say, 8 is just written as ln of 8. And once again, if you look on your calculator, you can see that there is an ln button, your ln button. Now, if you remember, e is a special number. It's equal to 2.7183, I believe. Let me just double check that. Yeah, 83. It's just a number that we often use for exponential and logarithmic functions, just because it shows up quite often. It's a very common number that appears to describe a lot of natural phenomenon. So that's why we often use this number here. It's kind of like how pi is used in circles. Like it's just a thing. So these are the two buttons that you're going to see on your calculator. Now, these buttons do not work for any other bases. So if you wanted to evaluate log base 2, you would have to do something to change this to one of these logs, which you can do. There is a rule called the change of base rule, which I'll talk about in the next video. Now, let's take a look at some basic properties of the logarithms. Some basic properties of logs. The first one is if you have log base c to the argument of 1, your logarithm is going to be equal to 0. This is very similar to the exponential rule, which states that if you have a base to the power of 0, your answer will become 1. Sorry, base to the exponent of 0 gives you a power of 1. The second property is when you have log base c to the argument of c will give you a logarithm of 1. So again, in exponential form, this is very similar to the rule that states that your base c to the exponent of 1 is equal to the power of c. The third property is if you have log base c to the argument of c to the exponent of x. This becomes x. Now the fourth rule is probably, or the fourth property I should say, is probably the most important one when it comes to solving logarithms and exponentials. And this is if you have a base c to the exponent of log base c x to the argument of x. This is going to be equal to x. Now this is only useful if x is greater than 0. So your x has to be positive, you can't have it as negative. Otherwise this won't work. So this one here, this is the most important one for when it comes to solving any exponential or logarithmic equations. So, thank you for listening in. The next video we'll be talking about the different rules that we can use to simplify logarithmic expressions.